Hey, this is Jeff, Georgia Fire Rescue Supply. We're talking more about thermal imagers and that they're not all created the same. This is another competitor's thermal imager here, and we're going to talk about colorization features of this imager versus a Bullard thermal imager. Colorization is often marketed as being a tool for safety for firefighters to make good sound decisions off of. And we're going to show that this imager has some issues that may create some gaps in good, safe decision making. What we're going to do here is we've got a camp stove right over here that we're going to light up, and we've got a piece of steel on it that we're going to heat up, and then we're going to project that image. If you look right over here, you'll see that on the wall is an actual projected image of what we're seeing through this thermal imager. And here we're looking at this steel being heated up. This particular imager starts showing colorization at just under 300 degrees. That area that's starting to colorize there is areas that's just under 300 degrees. But what we find is just above 300 degrees, when an object starts becoming heated up, that the color disappears. Although it's marketed as a tool for making safe firefighter decisions, and that when you see color in their superheated areas that mean something for decision making, we see that once this area starts getting really heated up, that the color disappears. Now, this creates a major concern for safety's sake and for decision making purposes. This steel plate has gotten no cooler. The danger has not lessened at all, but the color, which was a tool for making safe decisions, has disappeared now. And what we see is just above 300 degrees this colorization left us, and we will not see that colorization come back into view at all until we reach 850 degrees. We'll see it coming back. Now, our turnout gear and our protective clothing that we wear, a lot of our standards are based on what kind of damage is received when we start seeing 500 degree exposures. So there are elements of danger present, and very present, between that window of 300 degrees and 850 degrees. But we don't have that tool available in this particular competitor's imager. We're going to bring a cutting torch in and heat this piece of metal up, and we're going to get it really hot now, and we'll see that the colorization starts coming back into view when this piece of metal starts being heated up to 850 degrees. Now we start seeing some little areas where we start seeing some appear as the metal is being heated, and it comes back to us. But the whole point is we had a range of several hundred degrees that was present of high heat with no colorization at all. Alright, so we'll take the torch out now, and as this surface temperature would cool back down below that 850 degree mark, we would start seeing that colorization disappear again. And that just creates a little bit of confusion. That little bit of confusion can create huge safety errors for us on the actual fire scene. So as this continues to cool down, and then we're going to see that colorization disappear once again. And now it is gone. But although we still see on that bar graph to the right of the screen that we're in some pretty high temperatures, and if we were to take it for being fact, if we look at the digital readout at the bottom right hand of the screen, we see temperatures in the 700 to 800 degree ranges. So that creates an issue. Now, if you look over to me for a moment as I take this away, we're going to unplug that particular thermal imager, and we're going to plug into the system a Bullard thermal imaging system. What I'm plugging into now is a handheld receiver. We're going to transmit to it through this Bullard T320 thermal imager with a transmitter handle on it. Now, I'm going to scan back over to that same camp stove with a piece of metal. And you see color there. Bullard has a feature of colorization called red hot, super hot colorization, that when something is 500 degrees, it starts colorizing it as yellow. At 800 degrees and above, it starts colorizing it as orange, and 1,000 and above, it starts colorizing it as red. Now, this color doesn't go away. There's no gaps in that colorization. It's constant as long as high heat sources are present. We're going to bring the torch back into the view and heat up that metal, and we're going to get it to temperatures above 1,000 degrees. And the torch is now bringing the surface up where it's applying the heat to 1,000 degrees and above, and we see that red colorization occurring. I actually take the torch out of the picture now. So that feature is there for sound, safe decision making. That's a feature that's in Bullard that's different in a different competitor's model. Bullard's a solid platform made for firefighter safety and for them to make sound decisions off of. Alright, if you can scan back over to me. This is a Bullard thermal imager. If we can help you in any way, if you have any questions, you'd like for us to do a presentation, we are Georgia's Bullard thermal imaging dealer. Give us a call, we'd be glad to work with you, but just keep in mind, all thermal imagers are not created equal. Have a good day.